Dobrodošli. Ovo je Phoenix kanal.
The cosmos of the flat Earth is entirely above its surface, but the cosmos of the globe completely surrounds it. I can't imagine that anyone would think that the motion of celestial bodies would look the same. But all the time I hear flat earthers say, you don't look at the sky to determine the shape of the Earth's surface. So I'm going to show you a few sunrise time lapses between the 11th of March and the 21st of June, and we'll see if this is evidence that supports a flat Earth or a globe. I use the sunset time-lapse setting on my P900, and what it does is it takes a photograph every 10 seconds for 50 minutes, and then it combines this into a 10-second long movie. The first video is from the 11th of March. The sun is already above the building in the distance, and this is a 50-minute time-lapse. So 50 minutes will take the sun to the top of that bracket. And I'm sure you noticed that the sun rises at a very steep angle to the horizon. The 20th of March was the equinox, so that is looking to the east, and we had cloud cover that day, so I wasn't able to get a video. So this video is on the 24th of March, and this again is another 50-minute time lapse. So again, the sun is going to rise to the top of the bracket, which represents 50 minutes, and I am measuring to the center of the sun. Now the sun is rising at an angle that's about 13 degrees off from perfectly perpendicular, and this is because I live in Bangkok, Thailand, and we are about 13 degrees north of the equator. Now the sun moves 15 degrees per hour, so 50 minutes represents 12.5 degrees. These brackets are scaled to represent 1 hour or 15 degrees, so I can estimate that the sun was here an hour after this video started. Now it really doesn't take much critical thought to understand that the sun is going to be on that same path before sunrise, so I could estimate that the sun was down here an hour before this video was taken, and this of course is very strong evidence supporting the globe. Next, I'm going to show you a few sunrise time lapses that were taken around the 21st of June. Now, these first two videos were taken from the balcony off of our living room. Now, the rest of these videos are taken through our bedroom window, so the camera is pointing a little bit farther to the north, and over on the right here, you can see the location of the first two sunrise time lapses. And over here, this is the approximate location of northeast. This is on the 2nd of June, and this is a combination of two 50-minute time lapses for a total of an hour and 40 minutes. Now you're going to see a lot of clouds forming in updraft. This is during the rainy season when we get a lot of thunderstorms, but none of these updrafts were strong enough to form thunderheads. Also, if you look at the top of the screen here, in some of these videos you're going to catch some black flecks, and you might even see the outline of a sparrow because they're often out in the morning catching their breakfast. Now, watching clouds in time lapses has always fascinated me because they always seem to move and form differently than what you think they do. And here comes the sun above the buildings. This is another hour and 40-minute long time lapse on the 6th of June, and you'll see a crescent moon rising up in the upper right. Now it almost looks like that moon is moving with the clouds. And you'll see the sun appearing about halfway up between that gap between the buildings. This is the next day on the 7th of June, and again you're going to see the crescent moon, but it's going to fade out at about the top of the arrow. Now when you see the moon like this, you have to wonder why flat earthers came up with the silly idea that the moon is self-lit. It's also interesting that the high-level clouds are coming towards us, but the low-level clouds are going away from us. And finally, this is the solstice, the 21st of June. So of course, this is the most northerly sunrise that I see. And you're going to see the sun rising just above the right corner of that middle building. And this is looking out the other bedroom window towards downtown Bangkok for the sunset on the solstice. This is a combination of three 50-minute time lapses, and you can see that the sun is angling down in the other direction towards the right. Also in the background, you can see a very powerful updraft. This did form into a thunderhead. If you look down in the lower left right now, you can see some rain that is in the background there. And later that evening, we had some very severe thunderstorms hit us. And of course, that sun is going to continue on the same path below the horizon as it heads back to the east to rise again in the morning. There is absolutely no way that this is a sun orbiting around the North Pole on a flat Earth. So looking back to the east, these are the observed locations of the sunrises I see on the June solstice, both of the equinoxes, and the December solstice. If you notice the sunrise times, you saw that there wasn't much of a difference between the March sunrises and the June solstice sunrise. In fact, there's only a 31-minute difference between the equinox sunrise and the June solstice sunrise. There's only an hour and 37-minute difference in day length between December and June. Now on the equinox, the day length is 12 hours and 6 minutes, and many flat earthers will claim this is evidence that we don't live on a globe, because it's not exactly 12 hours. Well, there's a couple of good reasons for this. First of all, sunrise is not measured when the sun is half above and half below the horizon. Sunrise is the moment when the upper rim of the sun appears on the horizon in the morning. And of course, since we have an atmosphere, we have refraction, and this typically causes looming, so the actual sun is about a half a degree below the horizon. So it is a combination of both of these that add a few extra minutes for the day length time. Of course, what the flat Earth community cannot do is explain these sunrises on a flat Earth. So here's the flat Earth. In the center here, you can see the location of Bangkok. We're in between the Tropic of Cancer and the equator. Down here, we have the Tropic of Capricorn, and of course, the North Pole up here. Now in their model, the sun somehow magically oscillates between the Tropic of Capricorn to the Tropic of Cancer and back again during the course of the year. Now on the equinox, the sun path is above the equator, and since you have about equal 12 hours of day and night, that means that from Bangkok we would see sunrise over here and sunset over here. This is from time-and-date.com, and this matches what I see. Sunrise is 90 degrees to the east, and sunset is 270 degrees to the west. And if we throw a compass on my location, we can see that this is a major fail for the flat Earth. This would be the location of sunrise and sunset on the June solstice when the sun is above the Tropic of Cancer and our days are about 50 minutes longer. But again, a compass on my location shows that this is a major fail from what I actually see. And finally, this is the December solstice when the sun is over the Tropic of Capricorn and we have our shortest day length of 11 hours and 19 minutes. Well, not even close, because I actually see sunrise and sunset to the south of me, not to the north of me. Now the funny thing is that many flat earthers actually reject this map as a representation of their flat Earth because they're smart enough to understand that it is a total reification fallacy that cannot explain observations that we really see. but for some reason, they're not smart enough to reject the flat Earth, and they aren't smart enough to understand that the globe explains these observations perfectly. On the globe, it is the tilt of the axis that causes the changes that we all see during the course of the year. So this is the location of Bangkok on the globe, and the vertical line is the axis of rotation. And during the equinox, the terminator line, or the dividing line between day and night, is in alignment with the axis of rotation. And when I put a compass on my location, this matches reality. I see the sun rising to the east. During the June solstice, the North Pole is tilted towards the sun. And again, when I put a compass on my location, this matches reality. This is where I see the sunrise. And of course, during the December solstice, it is the South Pole that is facing towards the sun. And surprise, surprise, when we put a compass on my location, again, the direction of sunrise matches what I see in reality. So I trust observations that I have personally observed. And the model on the left is a fantasy. The model on the right is our reality.
Produkcija FE Kanal.